Here's a communication problem on polynomial inequalities. The question is, a polynomial function that has no real zeros will always be exclusively positive or negative. However, if given the zeros of a function and the related intervals, if a polynomial is negative over any interval, is it certain that the polynomial will be positive over the sequential interval? Explain and provide a graph of polynomial that illustrates your answer. Well, let me first sketch a graph and then explain you the situation, right? That could help us more about this particular question. So I'm just sketching a general graph here. Let's say we have a function like this kind of, right? Let's say this is our function. Now let's read the question and try to understand what the question is saying. It is saying a polynomial function that has no real zeros. That means the graph could be like, let me sketch one with no real zeros, right? So I'm purposely taking an even graph since this even degree function can have no real zeros, right? If we take odd degree function, it has to cross the x-axis. So a polynomial function that has no real zeros will always be exclusively positive or negative. So it could be either like this, or we could even draw like this, right? So exclusively positive or negative. That's what it means. Then, however, if given the zeros of a function and related intervals, if a polynomial is negative over an interval, is it certain that the polynomial will be positive over sequential interval? It says given the zeros like this. These are the zeros, right? Is it certain that if it is negative in this interval, then after the zero it will be positive? And if it is positive, after the zero will it be negative? Is that certain? That is the question. Correct? It says, however, if given the zeros of a function and the related intervals, if a polynomial is negative over any interval, is it certain that the polynomial will be positive over sequential interval? Explain and provide a graph of a polynomial that illustrates your answer. So the answer is not always. You can see from here that these are my zeros. The polynomial is negative, it changes to positive. From positive it changes to negative as it crosses the zero. But after this zero, which is kind of even degree zero, the polynomial turns and doesn't become positive at all. So it remains negative, zero, negative. It doesn't go to positive, right? So it really depends on the type of zero. So the answer here is that it depends on the type of zero. If the zero is even degree, if the zero is even degree, in that case, if it is negative, it doesn't become positive in the subsequent interval, right? If the zero is even degree, then that is not true. That means if from negative, it goes back to negative. Do you see that? It touches zero and goes back to negative. If it is positive, then it turns back, right? So it goes from positive to positive only. If the zero is even degree, like this, right? Or you should say if zero is zero, I should use the word order or multiplicity, or another word is multiplicity, right? But if the zero is having odd multiplicity, right? In that case, the sign will change. If zero is of odd multiplicity, then the sign changes. If it is linear, as you know, let's see all the zeros here, right? If it is odd and if it is linear, it goes like this. If it is like cubic, it changes like this. Higher cubic will be more flatter than this, right? So this happens when we have odd degree zero. But if we have an even degree zero, for example, in that case, the curve will turn like this. Do you see that? Or like this. It doesn't get across. The sign doesn't change if it is even multiplicity, right? So we are talking about multiplicity at this moment. So that is how we are going to explain this question. So the answer is that if it really depends on the type of zero. If we have a zero which is having odd multiplicity as shown here, then it changes from negative to positive or from positive to negative. But if the multiplicity is even like here, then it goes to zero and comes back to where it was, from negative to negative or from positive to positive. Correct? So that is the answer. Thank you.